Assalamu alaikum guys. Today's topic is angular momentum, commutation, relation. In classical mechanics, the angular momentum of a particle relative to the origin of a certain coordinate system is a vector quantity is given by. In classical mechanics, L show the angular momentum and arrow show the direction of vector quantity. And there R represent the position vector and P represent the linear momentum, where R is the position vector and P arrow is the linear momentum vector. We have R values is R is equal to I cap x plus j cap y plus k cap z, and linear momentum is equal to I cap px plus j cap py plus k cap pz. Now these values r and p's values put in the formula of angular momentum. We have L is equal to these values. We find the cross product. In equation of angular momentum, we have to find the cross product. The method of to finding the cross product is that first of all we write the vectors quantity I, j, k, and then value of r, x, y, and z, and then put the value of linear momentum px, py, and pz. When we find the value of I, then this term and this term we didn't write, and find the determinant, multiply with y and pz, and minus zp and py. In the same way, when we find the value of j, then minus sign is in the formula, and when we find the j value, then this term and this term we can't write, and x multiplied by pz and minus px multiply with z, and then we find the value of k. Then when we find the value of k, then this value and this value we can't write, x multiply with py and y multiply with px, and in the in between minus sign we write L is equal to I Lx plus j cap Ly plus k cap Lz. Therefore, Lx value of Lx, find ypz minus zpy, and value of Lz is this value, and value of Lz means angular momentum along to z axis is this value. In order to study the dynamical quantity angular momentum in quantum mechanics, we will construct a corresponding operators. This is done by using the components of momentum operators along x-axis, along y-axis, and along z-axis. With these operators, angular momentum components in equation 3.7, 3.8, and 3.9. These values can be written in the operator form as these values we can write in the operator forms. Angular momentum in x direction have these values, and angular momentum have in y direction have these values, and angular momentum in z axis have this value. So commutation rule for the component of orbital angular momentum with position. Consider commutation rule for Lx and x. What is commutation rule? When two values a and b in this bracket, then we write ab minus ba. In this by using this formula and commutation rule, we write value of Lx and x in this bracket. First of all, put the value of Lx in bracket, and x is written as it, and psi is also there, and I iota h cut take out the bracket, and then we have two values. This value is a and x value is b. Then we apply the commutation rule. First term a and x is b minus as it is, and then x b there and a values is there, and psi also here. Then iota h cut is as it, and we put x, we multiply x in this equation, and also put multiply with x in this term. We have gx d psi over dy minus yx d psi over dz, and there minus xz d psi over dy plus yx dy psi by dz as it, and then it is a plus term, and this is minus term, so we can cancel out this value and this value, and uh, it is a plus value, negative value, and it is plus value, so all term cancel each other, and we have zero value. So commutation of Lx and x is equal to 0. Similarly, Ly and y also is equal to 0, and Lz and z of commutation is also 0. Consider commutation rule for Lx and y. Now we are finding the commutation rule for Lx and y with psi. In the same way, similarly, I iota h cut and put the value of Lx in this equation, and y's value is, put y in it, psi also there, iota h cut as it is, and it is a value of a and it is a value of b. We apply a commutate value. First of all, we put this value and multiply with y, and then in minus, then y, put y first, and then second value is here, psi is also there. Now put y in this equation, and this y is put in this equation. When we putting, we have zy d psi over dy plus z psi minus y square d psi over dz minus yz d psi by dy plus y square d psi by dz. Y square, it is negative value and it is positive value, we can cancel out each other, and we have to uh, then remaining part is there, iota h cut z psi. Also lx y is equal to iota h cut and z is a remaining part. Similarly, we can prove that ly and z is equal to iota h cut x lz and x commutation rule is iota h cut y lx and z commutation rule is minus I h iota h cut y. And similarly